Hey TikTok, let's talk about the intermediate value theorem. So suppose in some town it's 70 degrees at noon, but by 5 p.m. it's cooled down to 60 degrees. What can you say for sure? Now it might have gotten warmer than 70 in the afternoon, but you don't know that for sure. However, because temperature is what we call a continuous function in mathematics, it means that every value between that initial 70 and that final 60 is going to be achieved at some time in that time frame. This is what's called the intermediate value theorem, and we learn about it in calculus, although in calculus classes, books tend to say proving this is beyond the scope of the course. And so that's why here in this course on real analysis on TikTok, we're going to actually explain why the theorem is true. It's important to notice that you do need a function to be continuous. For instance, if I told you the same thing, I told you at noon I had $70 in my bank account, but then at 5 p.m. I only had $60, that would not mean that there was guaranteed to be a time when I had exactly, $65.3, because the money could come out in discrete chunks and not in a continuous sort of way. So on the screen is a careful statement of what the intermediate value theorem says, and I like to think of the number w as representing what we want. And so if we have a continuous function and we want a value between the two known values that we have, there's actually guaranteed to be an input that'll give us exactly what we want. Now, how do we prove this? There are actually different ways to do it, but I like a way that's pretty similar to what we would call binary search in computer science. And what I also like about it is it turns into an algorithm that can help us find that solution for what we want. And basically the process is this. You just start with your two endpoints, in our case maybe noon and 5, and then just pick the time halfway in between and check the temperature at that point. Now we have 3 data points, and now the value we want is gotta either be between the first 2 or the last 2. And so we're just going to reduce to that case, but now we have a time frame that's half as big as we had before. As we repeat this, we get smaller and smaller intervals that are converging to some point on our number line, and those intervals all have to contain as outputs the value that we wanted. If you check some details using continuity, whatever those intervals are approaching will have the output exactly that you wanted. This is very similar to the technique you've probably done on a graphing calculator where you just zoom in on the graph until you can find where it crosses the axis. Since we're just testing points and eventually trying to find convergence, it's very similar to what you would do visually by zooming in.